Pseudo and Rage.
Yay, there we go. We're here now.
Hello.
How's it going? Now that I've nailed the intro, happy Saturday, everybody! And GlenCon, thank you for the resub. 7 months excitement. It's called Grinning Squinting Face, but it's spelled U plus 1F606.
Unicode.
Yep. I want a song called this. But it actually makes me think of, so if you're a geek and you don't know who Monzi is, you gotta check out Monzi. He was a Stanford comp sci student who in his spare time invented nerdcore rap, which is basically comp sci gangster rap. And in one of his songs...
it's exactly as awesome as it sounds.
It really is as awesome as it sounds. And in one of his songs, as it's starting, he goes, "Yo, MC++, if you're such a hardcore computer scientist, why don't your tracks on your album begin in 0, bitch?"
Zero index, all the things. Including time.
Isn't it? 24-hour time is 0 indexed.
Yep.
Yeah, 12-hour time is for scrubs, though.
Yep. That's what I'm saying. 24-hour time. There you go. So, game dev basics for non-dev people. Let me share this with people. So this is, it's not going to be a comprehensive course. Not going to be anything fantastic like that. But it will be lots of fun, interesting little notes that'll help you learn a bit about the game you're playing and how the game you're playing is made. And or give you the real basics that you can start looking into if dev is really something you want to explore more. But we do want to keep it fun and interesting. So it is a Q&A session as well. If you have any questions about like, hey, how did they actually do this in the game? Ask. That's what this is all about. We'll do our best. We may not know every single subject, but we'll know at least something about most of them.
Also, we should probably change the on-screen title.
Nah.
Everything is RPG builds now.
Thank you, RageBot. Thank you very much. I'll get that set up. So, does anybody actually have any questions that they want to know about before we start? Otherwise, we'll get the ball rolling with something not short and somewhat interesting. Have at. I'll ask as we go. So, one of the things I wanted to start with and definitely talk about was the asset creation pipeline. Because I think it's a really interesting process. It's got way more steps than anyone really knows. A lot of work goes into these things. And people don't truly appreciate it. They just like, hey, this thing looks ugly. Like, yeah, it looks ugly by the time it gets into the game. You should have seen it before it got into the game. And you should have seen all the work it took to put it in the game. That's
especially
where the time is.
With ancient file compression techniques and the ability to render only a few polygons at a time. Like it's not like the artists back in the day just made bad art. No, they're still talented people. They're still incredibly talented people. It's just that we could only show it in certain ways.
Yeah, we'll get into the pains that they went through later, but let's start in retro asset creation pipeline era, and we all know a bit about this. I know I've made a couple tile sheet games in my time. I'm sure Pseudo's worked with tile sheets a few times. I see Rage smiling like, I know what a tile sheet is.
I know that I don't want to use them again.
I liked working with tile sheets. It's fun and simple and easy to learn, and you recognize the term. You don't know what a tile sheet is? Okay, there we go. What is a tile sheet? Do you understand what a tile is? What is a tile? Okay. Does anybody want to jump in on what is a tile? You've only made one game on your own despite being in the industry for over 2 years. No problem. No problem. That's why we do this. That's why we do this. So a tile is one of the little squares in the game.
Yep.
Basically.
Little square. Yeah. Can represent things or lack thereof.
Sometimes it's sand. Sometimes it's water. Sometimes it's dirt. Sometimes it's a tree. Sometimes it's an enemy. Sometimes it's a player. All the different animations, each one is its own tile. So when you start getting like the SNES days of the fancy sword swinging animation and stuff, it was really just a flipbook animation of a bunch of still images done in pixel, stored on a sheet, and the computer goes, this frame I draw this part of the sheet, this frame I draw this part of the sheet, and this frame I draw this part of the sheet. Yeah, animation.
And this is closely tied to the technique of spriting and sprite sheets.
Yeah. Yeah, usually a tile is a sprite. Usually.
Not always.
Well, I guess all tiles are sprites, not all sprites are tiles.
Yeah.
Tile is a sprite in a set grid used for creating maps. So, okay, let's here. I'll grab a quick image of a sprite sheet. I think that's what Suda was saying. It was a little quiet.
I can kind of walk through why developers use these things, and I'll bring that up while you bring up the image. So basically, if you had, let's say, like a character art, if you wanted to, bring that on screen or show it, it would be it would take time to, pull that data from somewhere and then display it. Whereas what you do with a tile sheet or a sprite sheet is you would load the entire image at once, and then the application would just display segments of it. Typically, tile sheets are broken down into like 8 pixel by 8 pixel tiles, and then you have multiple of those tiles that make up the whole sheet. You would tell a section, you know what, take these tiles here and place them in these locations, and you don't have to load it for each one of those. You already have the image loaded, and then your application, the game, knows where to put those respective tiles, and then from that you can build, the maps, you can build the characters, you basically build what goes onto the screen.
Okay, so this one is a good example of being able to see the square breakups on these. And as we load these for different purposes, you can create some really interesting and complex stuff, but it's hard to see. So when I pull this one in now, where we can now see a square here, a square here. Actually, this is probably a square here, 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 and there's 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is all grass. This one's grass and a little top edge. And with this, you can expand them out. Same with these hills. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9. And with that, you can blow them out. So even here, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you see how it transfers from the light stone to the dark stone? So this is set up so that once you've set up the outside edge, you could then transition the light into this dark, have patches of dark all through here, and all from this one little set. And what you're doing is creating transitions, right? So we've got grass to light stone, grass to dark stone to light stone, patches of stuff you can put in the light stone. As you blow this out and get creative with it, you can create massive complex maps from this tiny set of images on the screen right here, just with a little bit of artistic creativity. To the point
And
where
it saves a huge amount of resources, both from a art creation point and from a loading time point and from a memory consumption point. Because now you've only had to load this once rather than a bunch of different configurations of the small chunks inside these tiles. So now that you've got all these tiles, you can say, okay, well, I want to have a big mass of light stone, but then we're going into a city, so I'm going to start putting the edge of the cobblestone right here, and then I'm going to use the center tile for the cobblestone to carry the road forward, and you can start building all sorts of things like that.
See here, as we start breaking this up into the tiles, you can see this is a stone top, and then this is a stone wall, so they made it one tile deep. Stair, 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 grass. Here you can see where the grass transitions, otherwise you just got solid grass, and you'll see that solid grass texture repeated here and there. Right here, that's the same tile, that's the same tile. Whenever you see this transition on the corner, it'll be the same tiles. This is a very small set of tiles to make this one. They're just well done tiles, so you don't notice the repetition as easily, and it's a great person who knew what they were doing that made this scene. This is a well done tile
until you really start thinking about it, you won't notice the repeats. It just looks like, you know, a little path with different branching arms that go to different locations, and you know there's a little ledge there with some stairs up it. It looks like a perfectly normal thing until you really start to digest and dissect what actually goes into making.
This is a much later generation, when these artists had been working with these tile sheets for years, and like their whole career had been making tile sheets and creating tiled maps. This is how they started. Right, and you can really start to see where the squares are, how everything lays out. You get a much better idea of what's actually going on here. You know, square, 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 square. It's pretty obvious that they're new at it.
Another thing you'll notice is that characters would always typically look the same, but would be distinguished usually by color or by like a slight tweak of the hair, because it would the bottom square of a body would be reused, but they'd basically just swap out the heads, and then you could have like two heads, but then swap through, you know, all the colors that were available to you at the time, and then that way you would kind of, you know, generate a lot of unique characters, but that information doesn't actually have to be in memory to change the color value. It doesn't need to be stored anywhere. You can just kind of tweak those in code.
Yeah, that's definitely something I wanted to talk about. So a tile sheet is a sheet of tiles, as we showed you. Can be loaded into memory at once, picked from to create complex maps. Does that make sense? Does anybody have any questions on the tile and tile sheet aspect of it?
You know, this is the first time I've ever actually put in any like real thought into tiles and tile sheeting, and so many games just made so much more sense.
Yep, that's why I like covering topics like this, because you just start realizing things like, oh, I see. Okay, so
and if you have a varied enough tile sheet, it's very difficult for people to pick out a repetition. For instance, one of my favorite examples of this is the StarCraft map editor. Like, their tile sheets are pretty big. They're not huge, but they're pretty big, and they're fairly varied. But when you were creating maps with it, you just click and drag and say, okay, I want this to be a road. And you go, whoop. And it would come out looking like a road. And unless you were paying very, very close attention, you wouldn't notice any repeats in it because there was sufficient variance to their tile sheets.
And they were super smart about their tile sheet applications and actually had variants built into you just dragging it.
Yeah.
They were pretty impressive in those days. What is
those map editors were really good. In what context?
I was looking at where I used map and game maps, like the level.
Hey, Storm Mega.
Hey, Storm Mega, welcome. How you doing today? A level for a game that can be loaded and drawn from a sprite sheet. Ooh. Got a tickle in the throat. Fine, thanks guys. Excellent. Glad to hear your day is good. He's been playing Final Fantasy Tactics lately, and that is a hell of a game. I mean, it'll beat you senseless, and it won't ask for any forgiveness. But it's a hell of a game. So, one of the things I wanted to get into was sprite sheets, which is exactly kind of what Pseudo was touching on in just what he last said. Why do so many old games have lots of the same enemy that are different color? Does anyone know? Anyone in chat know the answer to that one?
Correct, GlenCon. A map is a configuration of different tiles in the tile sheet. And it's essentially just a long care array that represents different areas in the sprite sheet that can then be drawn tile by tile.
Memory. I mean, yes. But I mean, why did old game do X? Memory.
You're not technically wrong. It's just not the whole answer.
Yeah. Do you want to grab this one, Rage?
Sure. So like Storm Mega alluded to, it was memory constraints. We didn't have the hardware to be able to have individual sprites, individual tiles to make up those sprites. And exactly like GlenCon says, now that we've learned about tile sheets, we would assume that the enemy was stored once as a tile sheet or a sprite sheet, and then certain areas of the enemy were chroma altered based on render time changes. So you could say, instead of this chunk of this tile being green, we want it to be red.
So I added another question onto that, right above it, which now waylays right into the same thing. How is a pixel stored? When a pixel's in memory, what does it look like? It's got to be a thing, right? It's got to be able to be drawn. It's got to have some data behind it. It's not a red dot in memory.
Wouldn't that be cool if it was, though?
You imagine working with them? That'd be so weird.
Just get blasted by color anytime you open up the memory editor.
Location, color, and alpha. Yeah, if we go back far enough, they didn't even have an alpha channel. Alpha wasn't even a thing when it started. So I'm not even going to write this one down, but as a quick interesting note, before alpha existed, we stored it as a magenta pixel. And that's why if you look at a really old sprite sheet, the character will be surrounded by magenta. And then in the draw code, when it draws the pixel, it would just say, if the pixel's magenta, don't draw it. And they just didn't use that color in their game.
And yeah, the reason for that as well is because it turns out magenta is the least used color for most of the time. But technically speaking, like any color could be used, but they would dedicate one color to just not be drawn. And then that's how we did transparency for quite a while until we got alpha.
Yeah, alpha layers are wonderful.
Another cool factoid about doing transparency or faking transparency that Pseudo brought up when we were talking about this earlier is they would alternatingly draw or not draw shadows like every other frame in order to give an illusion of transparency. So big ups to Pseudo for that one.
So,
It basically plays on the optical illusion. You've probably seen the things where you have like a piece of paper, like flipbooks. It's how flipbooks work. Our eyes can't really disseminate the individual frames too well. So if you spam it fast enough, and luckily arcade machines would run at 59 to 60 hertz, and if you do every second frame as a shadow, you would interpret it as just the same image. You'd see both at once. It would combine the two in your brain. So it was a really neat way to do transparency when we didn't have the option for it back then.
Cool stuff.
Yep, very cool. We've blown Glencon's mind already. How is a pixel stored? Well, a quick hint on how is a pixel stored, since I'm Glencon's probably almost there. You can look at how they changed a pixel being stored on how the colors changed. Do you remember the days of Windows 95 when you would boot it and you'd be like, oh, it looks ugly, and you had to change it to 16 million colors instead of the smaller one? That was because we had more memory for bigger pixel data. We could put more colors in them.
Yay!
I love colors. They're wonderful. People today have, that just started using computers will never understand changing your color bit rate. Like, what's that?
They will never understand going from 8-bit color to 16-bit color and having that blow your mind.
Hey, Val with the host. Welcome, Val and viewers. I'll say it again when Val himself gets in, but welcome, viewers. Val's always a little tardy to the party.
It's okay, though. We still love Val.
Oh, we love Val. I've been on his stream all day. He's been playing Bloodborne. That's how you get me. So, how is a pixel stored? We've been waiting long enough. Rage has already jumped the gun a couple times. Go ahead. How's a pixel stored?
I want to say it. I want to explain. I want to teach people. Pixels were stored with, like Glencon said, their location data and a byte of information. So you would get 8 bits, generally storing in a hex format in order to compress the data as small as possible and be able to represent, 8 bits of color, 8-bit color, or 16 bits of color, 16-bit color, and represent more colors that way.
At the end, you can look at it as 3 numbers. Today, their numbers up to 255. And you can literally edit them like it was an array of ints of values once they're all translated when they're being drawn. And that is R, G, V. There's your spectrum. So once you've got the thing drawn, you could even just store a little formula that color shifts, and then instead of storing a big sprite and redrawing it in a different color, you just run the little formula across the thing and it changes all the colors. Now it's a new enemy.
Yep.
And that's why you see the same sprite over and over and over again with different colors.
The naming that we have for colors now being, 8-bit, 16-bit, 32-bit color is somewhat of a giveaway for how they were stored if you understand a little bit about computer science. So initially, let's say an 8-bit color couldn't store as many values as a 16-bit color. An 8-bit color can only store 8 individual binary switches of data. So you only have so many mutations of that space. There's only so much possibility within that space. If you add another 8 and double it, you have n log n? Or no, nen. Exponentially increased your amount of storage space. You now have n to the power of n more storage. You double it again, it just blows up, growing geometrically. And that's why old computers, things like the NES, the Commodore 64, could only display very basic colors. They didn't have enough memory to store more detailed colors. Then when we moved to the 16-bit era, the Sega systems, the Super Nintendo jumped to mind. Everything was gorgeous all of a sudden. It wasn't because the artists used to suck. It was because we literally did not have the technology to store those colors.
Yeah, we didn't have the memory for it. Flat out. Do it. There's 8 bits there. That's what I'm showing you. 1 or 0?
Yeah.
1 or 0. Okay, here's a real quick one. Does anybody not know binary and want to learn how to count binary real quick before we move on out of sprite sheet era? And do you guys want to cover anything more about sprite sheets before we move on?
I just want to say my favorite number is 4.
Why?
No matter how you count it, this is 4.
That's fair. That's fair.
We could briefly touch on how animations were done using sprite sheets, because it's kind of neat when you load in a character.
I did kind of talk about it, but yeah, you go ahead if you want to. Do you want me to pull up
Sure.
a character sprite sheet example for you?
Sure. Yeah, sure. You can just Google sprite sheet. So basically, as with typical tile sheets, you'd have a single image that was loaded that was,
Hey, Val made it. Hey, Val.
Hey, Val.
Welcome, Val. We're talking sprite sheets right now, and if you have anything you ever wanted to know about how pixel graphics are done, now's the time to ask. Sorry to interrupt you, Pseudo. Go ahead.
No worries at all. So basically, you'd load in a single image, and then that image would be broken down like the other tile sheets were into typically what were 8x8 pixel squares. And then you would have your idle animation. You'd have the section of this image basically allocated for the different animations you're going to use. You would have your standing animation. You would have your walking animation, which for the most part, for a lot of games, was just 2 images that would swap back and forth to show legs moving. And then of course you would have your more in-depth animations of attacking and swinging. And how this would go is when you have your hardware sprite loaded, the way that it would do that is for the next frame, let's say if it's an 8-frame animation, when that animation's playing, when it goes to render it, it basically is just, when it goes to draw from that image, it's just drawing the next section of blocks over, and then does that for the next 8 frames, and it gives the illusion of, a predefined animation, but really all it's doing is it's loading a small subset of the sheet and scanning through it to the side until, it tells it to stop and go back to where the idle animation is. But on the actual game engine side, this whole image is loaded at once, and that's how we did animations. They weren't really pre-recorded or predefined. We just kind of play them off in real time.
Yep.
Well, real time-ish.
Yeah.
But just scanning through the sprite sheet at a predetermined frame rate, moving over 8 pixels, moving over 8 pixels, moving over 8 pixels.
Yeah. Typically, you would write a small chunk of code that was programmed specifically to work with the sprite sheets you've made, and then it would know when I'm running, I look here. When I'm running up, I look here. And then it would be able to load any character's sprite sheet and just replace that image in it. And then in the code, when you're working with it, it's not as onerous. You can really see it as running this way, running that way. But as you work down, it's just translating how you've built your sprite sheets out of these. Flipbook animations, yeah. Pixel games are just really complex flipbook animations. That's all they are.
Really complicated, really beautiful
Oh, yes.
flipbook animations.
Oh, yes.
Especially Chrono Trigger. Oh my goodness, the art for this game.
And once you look at it, there's not like there was a massive, massive sprite sheet. This is every sprite for the character Shadow when he's in your party. All of his attacks and everything. The only thing that changes is you'll notice there's no head on his weapon if you know the game. And that's because they have another sprite sheet for all of his weapons. So that as you change, that's how they used to do the different weapons in those days. So it would look at what weapon he's holding, and then it would load a different part of his weapon sprite sheet to put the different heads and different blades and different stuff like that in his hand. So it would just load 2 sprite sheets, one for the top of the weapon, one for him. The top of the weapon is a nice little one. Yeah, if you haven't played Chrono Trigger, you absolutely need to play Chrono Trigger. It's directly below Bloodborne in my rankings, and it's directly below Bloodborne in Rage's rankings, which I was super surprised by because he's not a big JRPG fan, but that's why I call this game transcendent. If you don't like JRPGs, you'll still probably like it. Pixel art will never go out of
characters are
style.
just so good.
Pixel art will never go out of style. That's one thing that depressed me about the PS1 generation, is Sony was encouraging a lot of their devs away from that in favor of 3D polygons. That's not the greatest wording for it. They weren't so much encouraging their devs away from it as much as refusing to fund any project that wasn't 3D or license. So...
What was the Valkyrie profile?
Yeah.
I think it was. Really cool blend of pixel art and 3D.
Yeah. One of the few ones you see in the, like, you see a couple in the early gen, like Suikoden is one of the only
Suikoden
ones you really
great.
see that's pixel art. And it was using the parallaxing and stuff at least, which was more than those older consoles could really pull off, but okay. .3D. What's the first step to creating an asset in today's 3D games? What's the first thing that started? How did those things start? Odin Sphere was PS1, wasn't it? Odin Sphere was PS1. Concept. Okay, you got me there.
Wrecked.
It starts with a pencil and a piece of paper. You're absolutely right. Everything in today's games still start with some asshole drawing in a sketchbook. That is absolutely how they begin today. How do they begin on the digital side of things after the concept is done, when they go to actually start making the asset that is going to show up in the game?
I actually don't know the answer to this one.
Yep, modeling is the first thing, but how does modeling start?
Fire up Maya.
Have you seen what like a basic model looks like? Like what they look like at the very beginning? When they're starting with a damn sphere and building it up? Yep, basically the wireframes is what you're looking at first. They won't do it in raw wireframe. They'll have like a gray cover over it. Hey, Grimkung, welcome. How's it going?
It's also referred to as a mesh, typically. The actual... And what it is it's the position of vertices. So, of course, if you're in 3D space, you have an object that is, of course, got an X, Y, and Z value. And to make 3D, you basically need to track where these dots are. And then you draw your polygons, which are triangles, between all the dots. And that's what makes your 3D object. So what modeling programs are doing is you're basically just creating these data files of dots or vertices that computers will then be able to figure out how to connect them and display them.
Start with one polygon, which gets stimulated by the concept art and multiplies via mitosis.
You know, that sounds just sciencey enough to be correct.
I think Ninja's right. He's licked the future of concept art evolution, and we can all retire now. How's it going, Ninja?
Yep.
Welcome. Good as cool beverage on a hot day. Oh, that's pretty awesome. That is pretty awesome. Welcome. So we just finished talking about tile sheets and how tile sheet graphics are done and all that fun stuff. We covered most of it, but if you do have any real questions, ask. We can still answer a couple. We're just moving on to how all these 3D assets in games actually get made and put together, and help you hopefully appreciate what really went into that tree that you just ran into with your bike. Goddamn tree.
Or ran into repeatedly while you weren't looking in Dark Souls.
Goddamn edge. That's what I usually run into. The edge! Gravity!
Gravity is the hardest boss.
Gravity is the hardest boss. Okay, sorry, Pseudo. You were talking about meshes.
Sure. You can probably pull up an image of just any mesh. There's a lot of kind of primitive shapes that you can start off with, and then you typically use those primitive shapes to build other shapes. But where we are now, we can render these vertices fast enough that we can work with a lot more complex polygons. But back when 3D was pretty new, you had a very limited amount of vertices that you could draw on screen at once. And the more you draw, the more it gets kind of exponential, the actual requirement for it. So you'll start seeing kind of, tips and tricks to really kind of stretch out these flat surfaces. And that's why, the original Tomb Raider was, so triangular. Everything was so pointy because everything is basically triangles, because it's the shortest amount of vertices you need to draw a shape. You just need 3. It's the smallest shape that you can draw in 3D. It's just 3. And then you put, four of those triangles together, and you can start building, rectangles and cubes, and put a lot of them together, and that's when you start getting, circles and surfaced areas.
See, those didn't start out looking like that. We always start, and as these 3D modeling tools that Pseudo's talking about using, like when you draw that orb, it does tons of polygons to make a nice, perfect sphere. Same with when you're doing all this stuff. At this point in the timeline, I want to point out that the assets are very beautiful. Very, very beautiful. Okay? Some of the assets, as they're creating them, could have more polygons than the main character is going to end up with at this stage in the game. A tree will have more polygons than the character once it gets to game. At the beginning.
And that's one of the things that's most exciting about the new storage technology in the PS5 is it has the bandwidth that we might actually be able to just take that starting asset before it's had polygon culling done on it and just use that.
Well, that's
super cool.
That's also in conjunction with the UE5 engine technology that they're bringing out.
Yeah,
Also
but it is the
that.
storage technology that enables
that allows the engine to do it. Yes, I'm 100% with you. It's a software and hardware mutual evolution moment, and it's gonna be special. We keep telling you it's gonna be special. And trust us, it's gonna be special. Buy a PS5. Okay. Yeah, I just wanted to make it clear that at this point, it's very, very, very high poly count. What a cool stream. I'm glad you like it, Van Jamma. Let's keep learning. You got any questions? You hit us with the questions. Let's do it. Okay. We can assume we've got our shape now. We've got our mesh. We've got
a thing.
We've got our elephant. We started out just sort of slapping polygons together, and we've made enough polygons that is an elephant. I mean, those are just polygons, but can anyone argue that that is an elephant?
I would say that is definitely an elephant.
Okay. So we've turned polygons into an elephant, but it definitely doesn't look like an elephant yet. It's just the shape of an elephant. Looks like a representation of an elephant in a computer. Okay, so how do we take that into that? What's the next step?
There are a lot of steps.
Well, there's many steps, but what's the
category.
next step, I'm saying? The next step. You have to add textures. Textures next?
That is correct, Van Jamma.
Textures next.
The textures are a very complicated thing to make, but they are what make your 3D model actually look like the thing that it's supposed to be.
So let me start. Let me start with one quick question. What's a texture?
Pseudo, you want to jump on that one?
Well, let's just.
I think you know this better than I do.
1 sec, and then we'll let Pseudo make everyone feel stupid.
It is magic. It is, as Glenn said, it is so much easier to
100%.
say it's magic. It is amazing that we can do this and that people have figured this out.
We'll go into the different layers that go into these textures as much as we can. Like, we only understand the surface level, but at least we understand most of the surface level, and that's sort of where the mind-blowing part is anyway. The rest of it is just confusing.
Yeah, I will keep the technical explanation as brief as I can. But this is stuff that I've always loved, and I went to school for it for a couple of years, and it's just fascinating, and it's so hard to work with. It's amazing what we can do with them. But yeah, as we said, the next step is texturing, and what a texture is just basically what the definition is. The kind of look and feel of an object. You basically are giving it its skin, because as we can see with its elephant, if we don't have a texture on it, it's just going to be like a single color. We haven't specified what color to display on any of the things. So we'll make something called a texture map that will apply to this model, and these things are super kind of crazy looking, and you probably would have even recognized that it's an elephant if you were to look at a texture map. But the premise works surprisingly very similar to how sprite sheets and tile sheets worked, where we take a single image and we load it in, but then in the actual code in the engine we specify regions and areas of the actual image of the actual part of the model to put the skin on. So Des, if you can pull up
find a good texture map right now.
Sure, you can do like texture character map or something, and you'll see there's the face, there's the shoulders, there's the legs, but it's all laid out all flat, and then basically in the game engine we basically just say, all right, well, this is the head location, so on this 3D model where these vertices are, draw it from this location of this image, and that's how we start kind of applying these things. So as you can see, the texture map image is crazy looking. Like, what is this? This is terrifying. It's like someone got stuck in a blender and this is what we pulled out of. But as you can see where the head is, you can see where the neck is, you can see where the shoulder pads are. We basically just take this one because it's so much easier, and it saves on memory just to try to pack everything we can into one image and just load that single image and keep it in memory than to store an image as a face or store a thing as this is the back, this is all this. It's so much easier to all right, well, we'll load the vertices, we'll load the mesh model for the character, and then we load the texture map for the model, and they're both a single file and they're both stored in a specific location that's easy for the games to find and organize. So
this is a nice example because the model and character is so simple that you can really see how it's really just a basic mesh underneath him. It's just wireframe, one piece here, one piece here, a little bit of depth, and this is just laid and wrapped over him like a shrink wrap. Does this hairy bastard have a light map? No, he does not. He does not at all, and that's why I used this as a super simple example, because we want to start at the beginning and we'll go a little bit more into light mapping after. That's when it gets really crazy. I don't even know how they... Actually, Pseudo, if you can go a little deeper on the light mapping, even I'd be curious to know a little bit more about what goes on there. 'Cause that's really crazy stuff. Okay, but everyone can see how, like, like his shirt here. It looks like it's got depth, and it looks like the shirt is layered on him. But when you look at it here, it's just the way the shading is drawn on the sheet. He's got
and then it gets
on his back,
folded around his torso.
Yeah. Really, really good example. So, light mapping.
If you thought this was complicated, it gets so much worse. I can explain it fairly easily, probably using the new Minecraft ray tracing as an example.
Can I ask what programs are used? I've heard of Maya. Maya would be used more for the modeling. Yeah. What is used for the texturing? I think they're same thing as
no idea.
I think you can still use the modeling software for the texturing, I think.
Yeah, they usually have it built in as well, but you can use things such as like Substance Painter, and there's a lot of like super specialized tools for this you can basically load in your models and kind of paint them, and then it'll automatically create your texture maps. But back in the day, you actually just had to make those texture maps before we created these tools for it. A lot of times you would just go by hand, and this is where the face is going to be, and this is kind of how it is. You would load it up and see how it looks, and a bunch of trial and error for a while. It's amazing, when this technology was new, the kind of hacks and tricks that we were working with to really save on that crucial memory.
And then you get fun things in the early stages of games where a texture isn't quite aligned and the head's just on sideways.
Yep. Oh, there's a nice one. Yes, I love this one. It's one of the Unity examples. Classic one.
Correct, Ninja.
I wish.
So, that is what light mapping looks like if you look at it. So, what is light mapping for, and what does it actually do to the texture? Does anybody know what effect light mapping actually applies to the texture, why we use light mapping, and what its purpose is in a game?
I know. I actually know this part.
That's a light map. Simulate depth? Yes. Yes, exactly. Light maps are for creating depth. You know what the number one thing to tell us what depth is for our eyes? You know what helps more than anything to tell our eyes what depth is? Really interesting. Yes, shadows. Go ahead, Rage.
That's what I was going to say.
That's how much he knows. Honestly, that's about how much I know about this one. So this is where we go pseudo.
Okay, so I'll see if I can find a better image. But typically, you'll notice that if you wanted to have like a rocky surface, and let's say that you have to, if you're drawing with polygons and vertices, it's going to be a lot of little dots to kind of like build a rough surface. It's a lot of in and out, like in volumetrics. And you'll notice that if you were to remove the light maps from meshes and textures, they'll just be completely flat. Because you can have, let's say, a wall, and it can just be completely flat. That's only going to be like 4 vertices to draw. But you want to give it some depth. You use something called a light map. And as we're saying, it's kind of what you can give it depth. So it's a flat surface, but now we can figure out through just wild light calculations, I won't dive too much into it, but you give it this file that basically says, like, this is how light will interact with this object. This is where, light will be darker, this is where light will be brighter, this is where it'll shine, this is where a shadow will cast. And then when you run it through a game engine, and a light source is shining onto this mesh with this light map onto it, you'll be able to calculate how this will look. And then this is a great example. So the actual mesh and vertice for this will be flat, but due to how we display it, we can do a lot of clever things of giving that perception of depth and really giving that texture and feel. And a combination of a really high quality texture and a really high quality light map gives the most realistic looking feel. And then there's a lot more that goes into it. This is a really kind of basic introduction to it. It is an incredibly complex topic, and even I've only really dipped my toes into it, and I've been looking into this for years and implementing it. It is just it's crazy what we can do, and it really is like we basically, what video games are is just smoke and mirrors, and we're just tricking our brains into thinking things are there. The thing that usually blows my mind, and that it's a hilarious comparison to me, is that modern game consoles, all they do is they're just machines that move dots on your TV around. It's always 2D. It's just a bunch of dots, and all that machine does is it just moves a bunch of dots around. You push a button on a controller, and then that machine just moves dots. But from all the math and all the work we put into it, to our brains, those dots are these entirely vast, massive worlds that are detailed in 3D and you can explore. But in reality, it's just dots. All we do is we calculate how this would look in a 3D world, and then we translate it to just 2D flat and draw it in just dots, and it just blows my mind that we're able to do this.
The best physics are approximated ones. You're not wrong at all. Has anybody ever played a game where the jump physics and run physics are programmed to real Earth and real human levels?
It's the most boring thing in the world.
Oh, it's horrible. As soon as you play it, you're like, why am I so slow in this game? Why can't my character jump worth a damn? Turns out humans are slow and they can't jump worth a damn.
Yep.
You also fall very fast. And when you play games that have a realistic falling speed, it feels weird to us because we've been so used to it. And it's the same thing with like Hollywood, how people always go, well, Hollywood's so unrealistic. It's like, well, have you ever watched like a realistic Hollywood movie? It's boring as shit. It's like, turns out like we've just
Turns
been
out
kind
reality
of
isn't fun.
yeah, we've just been kind of conditioned with this extra flavoring. And on the physics thing, I think that a lot of games use is something that's called coyote time, which is pulled from the old Wile E. Coyote cartoons, where basically you'll notice that, especially a lot of platformers, you can fall off the platform, but you'll still be able to jump, or you won't fall right away. There's a slight little bit of delay before you start falling, because they found that, you know, if you play a game that has immediately falling, it just feels bad, because you feel like you don't have enough control, because we don't have the reaction time to really calculate those jumps. And that's what a lot of games, you know, back in the NES era had, is as soon as you're not touching that platform, you fall, and it just feels terrible. You feel like you can never make those jumps because you just feel like you can't actually get too close to those ledges. So we fake it by giving you a little bit extra time to make that jump, where in reality, if it was simulated, you would just be falling. But to us, it just feels so much better and allows it to be playable.
Hey, CarTube and viewers, welcome!
Yeah, we got to get that out of the way.
welcome everyone. So we're talking
I have
about...
a point.
Hold it, don't forget it. I gotta tell them all. We're talking about game assets right now. We've moved into the 3D. We've gone over 2D already. We're happy to review a little bit of 2D if people have some cool questions about how 2D stuff worked. But right now we're talking about light mapping. This is how we take a flat, basic object that's been rendered and make it look like this amazing wall that you see right here. Okay. Constantly falling off jumps. I played a 2D platformer GBA game where they fucked up and didn't put the coyote time when jumping off a platform, and it was messing me up hard. Yeah, no worries.
Yep. And then you miss the jump and it's terrible, and it feels terrible every single time. And that's also why when you're doing position calculations for video games, it's often done so that as long as part of your character is still on the ledge or like reasonably close to the ledge, you can stand there.
That's why we call
because
it
otherwise otherwise you just fall off and it feels terrible every single time.
Yeah, Mega Manning. Mega Manning's the thing. That's one of the most famous ones for it. He's got a pixel of a toe on the thing. He's entirely hanging off.
That's fine. He can stand there. It's okay.
Yeah, we'll talk about some of them later, but there really are just an amazing amount of little kind of just tweaks and kind of hacks to just make the games feel like they do, that we have no idea that's what they're actually doing. Like I said, like with coyote timing and a bunch of other stuff where, you know, a lot of the time the game actually lies to us. An example we'll go into later is with like health bars and stuff like that. Just because your health is full and just because it's almost empty doesn't mean that that's actually the values for it. Behind the scenes, we can do a lot of tweaking and a lot of kind of just fakery to give the illusion of, you know, a linear progressive. But like a lot of games, you'll find that last little bit of health you have is actually a lot more than your full health bar. But it gives you the illusion of, you know, you barely survived that conflict, or like it was a close call. You'll find that happens quite a bit in video games. You know, you survive with one health, a non-frequent amount, and that's on purpose. That's actually designed that way. Some games will actually give you iframes when you're about to die for a couple seconds, just to kind of give you that thrill of a close call.
They're programmed not to, because sneaking up on a dude who suddenly does 180 feels awful every time. It absolutely does. It's also impossible for a person to instantly turn 180.
But even just like turning back on yourself, they're not allowed to do that in the Arkham games because it is, for the most part, a stealth game. And you don't like the experience of walking up or sneaking up behind somebody who just immediately turns around and sees you. Feels real bad.
Interesting. Yeah. Lots of little things that go into making games not feel like shite. Like RNG. RNG is not usually fully random, almost never truly random unless you're playing XCOM, and that's why people bitch about it. But XCOM is truly random. It's not slanted against you. It's usually slanted more towards you so that you don't feel like you're being cheated. And XCOM's fair.
Yep. It turns out
To-
a 20% chance to miss is still a 20% chance to miss.
And even a 95% chance to hit is still a 1 in 20 to miss.
Yep. If you roll a 1, you still miss. No different than pen and paper. Not using an algorithm to simulate randomness. What does it use? Atmospheric noise.
Well, it'll use weighted randomness. So it'll be typically, well, depending on the feel of the game they want to have. If they want to like give the illusion of randomness but still have the game fun, they'll weight it in your favor. So let's say it's a 50-50 chance and it displays that. Under the hood, it's probably a 70% chance for it to succeed for you and a 30% chance for it to fail.
Or they'll implement it where that 95%, every once in a while you will miss. There is that chance. So 95% you miss, it happens, but then the next attack will be weighted more in your favor to hit. So you're not going to miss again, most likely after it.
There's also something to be said about computer random versus real random.
Yeah.
Computers are extremely bad at being random. Extremely bad. And as GlenCon noted, one of the ways that random.org does it is to pull data from atmospheric noise in order to generate a as close to random signal as it can. Because, and this is probably going a little too deep into it, but because computers are deterministic, you put the same input in, you get the same output every single time. And that is incredibly difficult to do randomness with.
Honestly, I don't like the fact that Diablo 3 changed from the full random loot. I think players would have adjusted to it and gotten used to it and stopped bitching about it as they started creating communities to trade with each other and realizing this valuable thing just means I get to meet other people and talk to other people and find something that they had that I wanted. Instead, they're like, oh, you guys don't want community? Okay, just go find your own drops. You're not even allowed to talk to each other.
Well, I mean, there's a whole heap of game design on the other side of that, which is problematic. Like the whole not having communities thing.
Yeah, it's different strokes, I guess. It's not what Diablo 2 was. It's such a stray in the opposite direction of what Diablo 2 was always pushing towards. But PoE offered exactly what Diablo 2 used to be. So,
yep,
it was fine. If you liked Diablo 2 and hated Diablo 3, and you haven't played Path of Exile, you should probably play that game. It's what you've been looking for. I promise you that. It was good. I loved it.
It is very, very good.
The earlier
and I say that as somebody who did enjoy the Diablo 3 and its eventual fixing of the loot system.
The earlier Fire Emblems are interesting because they use a 2-die average system that in practice ends up slightly weighting in the player's favor. Yep, exactly. It's actually, I use a similar system in pen and paper when we're rolling characters. It makes consistently good, but never amazing characters. No character wants to end up average or crappy. They want to feel strong. Let them end up with something they feel is strong, but not overpowered, and then just throw strong enemies at them. They're no stronger than they actually were, as if they were weak and you threw average enemies at them. They just feel better. I thought I read that D3 on launch skewed drops towards classes you weren't playing to push folks towards the auction house, but the actual reason was because everything was equal weighted? Yes, everything was just equally weighted, and people feel shitty when things don't come out their way, is basically what it boils down to.
Although I wouldn't put it past Activision to have actually weighted things against you. So if you're getting a good drop, the odds are you're not going to get it for your class. Because Activision.
Yeah.
I had a
something
sniper. Sorry, I just wanted to read the other comment before it scrolls too far. I had a sniper in XCOM 2 miss a 93% chance to miss on a stationary turret 3 times in a row, though. I don't want to believe anyone has that kind of abysmal luck. Well, unfortunately, Val, you have that kind of abysmal luck, apparently. It was a
RNG.
almost 1 in 10 chance, almost 1 in 10 chance to miss, a little under 1 in 10. That's pretty bad. That's quite low odds of missing all 3 of those shots. Yeah, that sucks. I'm sorry to hear that. It's happened to me before too. I've played enough XCOM where really shitty things should have happened to me statistically, and they have. But I've also had just like the most hilariously amazing things happen for me as well. So yeah, it really is random.
What I was just gonna say is humans actually, we really, really suck at actually perceiving and interpreting chance and probabilities. We have a really bad cognitive bias for it, and it's kind of why casinos are so big, because it's we just can't comprehend the probability. Things such as like even just flipping a coin. If you flipped 3 heads and then you're going to flip it again, you're probably going to bet that the next coin flip is going to be tails because, it's due. It's a 50% chance. I've gotten 3 heads. You know what? This next one's going to be tails, when actually the math is you're just as likely to get a heads as you are to get a tails. It's still just 50% chance. And then if you get...
No. See, here's the
probabilistic set theory.
Yeah, kind of.
Well, it depends on how you're looking. It depends on how you're looking at it, right? If you were to ask somebody, what are the odds of getting 4 heads in a row? That's going to be much lower. But if there's just been 3 heads and we isolate the coming toss to a single equation, it's still 50-50 on that toss.
Yeah. On that single toss, absolutely.
The point is the isolation of that, of the given one, which is how a lot of gambling and a lot of games work like that, is we have this isolated percentage of chances of winning when really, like, we don't. But, yeah, to us, we kind of get this weird intuition of, because it's a probability, these things are due. It's the same thing as, like, let's say the probability of getting struck by lightning is this huge number, and let's say you get struck by lightning, people will tend to think, like, you know what, it happened, it's not going to happen to me again, the odds are so astronomical. When nope, the odds are still the same, and it can actually just happen again. There's no rule saying that it can't just happen again. There's no rule saying that, these huge odds won't just happen twice in a row. It's just as likely to happen that day as it did another one, as long as it's like an isolated thing. If you're betting, if it's actually going to happen twice, but like, we have a really hard time perceiving it that way. To us, it's like, no, it happened. We're good for a while before this probability is due to arise. And it's the same thing when we play games that have percent chance. We're like, you know what? It's a 90% chance I'm gonna do it. Oh, it failed. 90% chance I'm gonna do it. Oh, it failed. And you're like, well, it's 90% chance I'm due for this to happen. When really it's like there are sets in that probability where you can go a large chain without getting it, and it still fits that model.
Thank you for the follow, Fafnir.
But yeah, there's how you ask the question is also very different. You can ask, say, what are the odds of this next coin flip being heads? And that will always be 50%. Always. But if you ask the question, what are the odds of all of my next 5 coin flips being heads? That will lead to a very different answer.
Yeah. But after the 3 flips are already done, the next flip is its own unique individual thing at that point. So its literal one flip is still 50-50 to call it heads or tails.
Yeah.
Another
probability math is complicated.
Math is complicated. People make a lot of money off of simple probability math.
Just to quickly add to that as well, a neat thing about that, so let's say if you were trying to get that 5 in a row coin flip, no matter what results you got for your 5 flips, it's technically the same result, the probability for the entire set. It's to actually gamble. This gets kind of hard to explain, but the actual, if you were to look at all the combinations of 5 or flipping a coin 5 times, to pick any of them is technically the same to pick the one that's 5 times in a row. You're just as likely to get it as all the other ones. It's very rare to get the exact one that you pick, and that's where the probability comes in. It's the same thing with shuffling a deck. The amount of permutations, the amount of different combinations that are in a deck of cards, the chances, whenever you shuffle a deck of cards, the chances of that deck of cards, that order of that sequence of cards, never existing before is actually very high. You've probably uniquely shuffled that deck of cards because there are just so many combinations. But the odds of getting that combination were so high, but you still get them every time you shuffle a deck of cards. It's this astronomical chance of you getting this permutation of this sequence of cards, but you do it. It's kind of crazy.
Yeah, 52 bang is a very, very big number, FYI. But yeah, we may have rambled a little bit about probability because probability is cool.
Yeah, it's a very, very deep and complicated subject that game designers and developers are constantly working on to make this experience more enjoyable. This is only because our hardware and software are inferior to those running the simulation we're in. Yup.
State machine. Why you no make random? Make random. Yeah. It no make random.
Well, I don't really want my state machine to be random. That's a pretty structured thing. I want my state machine to be in the right state. Most state machines actually have the problem with random states, like Sekiro, and thinking you're in the water when you're in the air.
I mean, that gets into the whole setting up of state transitioning again. And we did do a show on that already.
If you're into Soulsborne, or if you want to get into Soulsborne, definitely watch our stream that we did a while back called Getting Good State Machines. It's super, super, super helpful for how you approach every fight in the game and how to push the game in your favor, essentially. Great, great video. Come ask questions if you have them after that. So, okay, Pseudo. What comes after the light mapping? We've now got this mesh that looks like a thing, and we've wrapped a texture on it so it kind of looks like the thing, and then we've applied a light map so it even has some depth and shadowing, and now it really looks like the thing, and now the thing is standing there like this. What do we do?
So there's a big jump that we did to get to where we are now.
Do you want to go over any of it?
No, I'll just say the name. So there's like, of course, like shaders, and then the step to when you actually display a model, you have to do something called 2D projection. So this is the thing I was kind of talking about, how like an Xbox and a PS4, they're honestly just machines that move a bunch of 2D dots around on a screen. So you have this 3D model, and then the application needs to be able to calculate, how far away it is, and then it has to calculate how the texture is going to look from that far away, has to calculate how the lighting is going to be on it. So if it's up close, it's different. It gets incredibly crazy. So we're just going to leave it at like, there's some math that happens, there's a bunch of cool stuff that happens, but now we have a model that we can view in 3D space. And something called a camera, which is, what your screen is technically, it's a camera, it's a viewer, where you're seeing this 3D object in a 2D space. So now we probably want to make this object move around and give it some life, because games aren't too fun if you're just looking at a.
We got there.
Oh, I may have missed a step that I did want to go into a lot more. Is polyculling before texturing?
Polyculling happens in the engine at runtime, or at least it should.
Yeah.
Well, initial assets do have to be. Like they have a poly budget that they have to meet before it's put into engine, right?
Yeah.
So it's initially designed. So they actually have to chop down into their poly budget. So when does poly budget happen? Is that before the texture is applied?
No, it kind of depends. Like, this is where game engine architecture gets pretty complicated.
Yeah.
But textures will be stored on the VRAM of the graphics card for quite a while, and they don't really.
Well, I mean, so the asset in the game that's in memory is even still lower end than what was originally made, right? We're talking about, this is the original asset, much higher poly count than what's going to be on disk. When do we down render it so that it can be stored as a game asset? Because we have a set number of, so what we're talking about here is we've made this tree, right? Remember, we were talking about this tree that we've made has many polygons making it up. And I said it, at this point, would probably have more polygons than even your main character is likely to have. Now, every tree cannot be drawn that way. So when it's stored, we have to strip away polygons first, basically.
Yeah, there's lots of techniques to do this. It's kind of like the main thing from 3D graphics is, how do we cut down this polygon count? Because even in modern hardware, we still have basically like a hard limit to how many polygons our machines can draw. And now we're basically getting to like the millions, but it's still, there is a limit. We still have to be cognizant of it. And there's a lot of stuff that we can do. And tricks that we can do for the human brain to cut down this number, and some of them can happen in the actual creation, some can happen in the loading, there's sometimes compression. A lot of times this is where you start building into like the quality settings and quality. That's why when you crank your quality low, everything looks kind of flat and the textures are kind of bland, is because they're like, you know what, load in this texture file, but you know, only load like half the data we need. We'll just kind of figure out the rest from there. And then so that's we can like only load in lower quality things. Same as like, it's how a lot of kind of like length of distance rendering works. If you have an object that's, let's say, like a couple kilometers away and you're playing like an open world game, you probably don't need that tree that has 1 million polygons to render a kilometer away, because realistically speaking, when you render it on your like 4K screen even, it's only still going to be a few pixels. So like those the math to convert 1 million polygons into 4 pixels isn't really going to be worth it if you just load in a very low quality version of that texture and then just do the math on that instead.
Yeah, so essentially what I want you to really understand and take away when you're looking at that asset is they started by creating something really, really high-res beautiful to make it look like a nice tree, and then they have to take it back, and like even on the PS2 days, they would have it and then, okay, I have 100 polygons to work with now. How do I take this thing I've made and reduce it down to the point where it's only 100, where it might be at, you know, like thousands to tens of thousands at the time.
And nowadays there are tools that can help you do this, but it is a very complicated thing.
It is. So those like the characters you see in the early PlayStation games, actually I don't even think those had modeling utilities, did they? Like the early FF7 and whatnot. I think it was a lot of vertex drawing for the characters.
Yeah,
I don't actually know.
The studios would typically build their in-house tools, but a lot of the times it was very expensive software and computers that you would buy for this. And a lot of the times these are things that were used in 3D animation, which then developers had to hack to work for games. And these workstations were like $30,000 each at like their lower end. These were very, very designated, specialized hardware to be able to create these models. And then you have to scale it down to something that can run in real-time hardware, and it's just kind of amazing what we did for like PS1 era 3D.
Yeah, there's a really neat link with a technique called occlusion culling that Horizon Zero Dawn uses for its ability to run such a honestly breathtakingly beautiful game on limited hardware like the PS4. And I just pasted it into the Discord chat if you want to pull that up, Deus.
I can't.
Rip.
All of your
I'll
videos
post
will
it
disappear.
in Twitch chat.
And Deninja was hoping somebody can go into a little bit of what level of detail is and how they pull off different levels of detail. I think Pseudo already kind of did that when we were talking about the poly budgets.
Yeah, and LOD is essentially just different distances from the viewport that loads in different levels of detail, hence the name LOD, as the object gets closer or is able to be perceived by the player.
So here's a fun one that was just absolutely mind-blowing for me, and it's interesting because it's really relevant to level of detail and a few other things we're talking about. So with level of detail, you need to calculate constantly how far away things are from the player. You basically always want to know how far everything is away from the player. So when you're looking on the map, you've got to look where the player is on the map and where the things are on the map and do all the math back and forth to figure out. Well, it turns out when you're doing distance math on a surface like this, if one of the objects is at 0, 0, 0, it makes the rest of the math super easy to do. Like way easier to do, even for the system, much easier to do. So, in order to take advantage of this strange phenomenon in our math, your character is always at 0, 0, 0. Your character never moves. How they accomplish it making it look like you move is when you hit the direction, it moves the entire map The whole world moves under your feet, and it plays your running animation. You don't
No
move.
wonder people say gamers are entitled.
The for 3D, to really kind of understand how complex it can get, it's not even the character, it's your camera. Your camera has a position, and everything rotates around that.
Yeah.
And you usually, if like it, not everyone will do this. Like I said, there's so many different techniques that people use to accomplish this. But if you do this technique, your camera, which is your view, so imagine you're the observer, you don't move. Everything kind of just moves around you, because then you have like a central location to do your math with, and it's a lot easier to work with. But it can get, when you start working with it, it can kind of just start blowing your mind about how this all kind of works. It is so complicated, and it is so hella impressive of like the level that we're getting with.
And that's why you'll often see games where even when the camera moves around your character, that's not actually what's happening. It's rotating your character and the map with it. But you'll note that your character hasn't changed orientation, but the direction sound comes from will. And it's because it's based on the camera's location rather than the character's location.
Not always, though.
Not always,
Some
but
games
it does
do
happen
program
with quite a
sound
few
from
games.
Character location, which kind of throws me off, honestly. Warframe did something pretty weird with that in one of the expansions.
Do tell.
Yeah, what did they do? I like weird things. And I like Warframe. And you're talking about two things I like. I don't play it very much, but I did enjoy it. It's called Railjack and adds a party crew starship.
The ships are stationary on the map. Interesting. Ah, so they've just got the map moving around you to simulate flying through space.
Yeah, except one of Futurama's biggest nerd jokes, it was explained that their ship, yeah, I remember that one, never actually moves. It just moves the entire universe around it. That's how they're able to break the barriers of speed, because they're not actually breaking the barriers of speed. Their ship doesn't actually move. I do remember. That was a fantastic episode. I love Futurama.
Futurama is fantastic.
One of my favorite shows. To expand on what the Ninja was talking about, that's very frequent in a lot of games. A lot of the stuff that you see isn't actually what you think it is. One of my favorite examples is Fallout. I can't remember which one, if it was 3 New Vegas or which one it was in. Might have been New Vegas. I'd have to look
It's
this
clever,
up later. But
so
anyway,
it must have been New Vegas.
actually, I think it was probably 3. But either way, at one point in the game, you get into like a train. It's like a tram, like a subway tram, and it moves through a track. And
I love this.
The actual like post-mortem, like behind the scenes, the way they did that is, let's say if you're a game developer and you're a programmer, like, all right, well now I need to have the player walk into this train model we made, and now I need to program the train to move on this path and have this object. Well, depending on what the engine provided you with, you may not just have the ability to have an object that a player can stand in and then have it move. And the way they did this was they took an NPC controller, an AI controller, and they modeled it with the head of a train, and then that's what you get on. So when that train's moving, it's actually just a person that's basically got a train for a head that runs on this path, which is the train track, and that's actually what's happening, because that was the easiest and quickest way for them to do it. It's just hilarious. And like looking at like the models and the pictures of it, it's just like, yeah, if it's the easiest way, that's the way to do it. The player will never know. We can't really figure that out without actually diving in behind the scenes, and it works.
Yep, they could make NPCs, but they couldn't make inanimate objects move, so they just made it an NPC with a train head. I think Half-Life does that. Probably
it is actually a human model with a train for a head that runs along underground.
Yeah, it's pretty great. I didn't play Half-Life or Half-Life 2, so I'm not sure if they did that.
They probably do.
Yeah, it's fairly common because when you have like developer game engines, you will have player controllers, and a player controller isn't always the actual player. It just means it's something that can receive input and move. And when you program AI, a lot of the times it's the same thing as you're providing the same input as the player is, because it keeps it a bit more realistic. They can kind of move in the same ways, and then that makes making movable objects a lot easier too. Well, I have this code that I tell it, hey, I pushed up, so move this direction this many times. You just apply that now to the train, but instead of it being a person, it's just going to look like a train. Yeah, small tidbit, very interesting.
Yeah, it's just a small little fact, but I love that one because it is a nice example of how creative we have to get when we're making games sometimes. You've got this set of tools, and everyone thinks that you've got like the right tool for the job, and if the right tool for the job isn't there, you just make it and use it. No, it's way more jerry-rigged than that. Games are, they used to call it smoke and mirrors, but it's way more balsa wood and duct tape, I think.
On fire balsa wood and shiny duct tape.
Yeah, there we go. It creates smoke and mirror. Apparently in Fallout 3, the train is equipped onto the player's arm. Interesting. I thought the model showed the head, but either way, interesting.
The player gets something else. It's a bunch of complicated stuff, because what the camera sees is rendered differently from like world space. So like that's why in a lot of games, and especially in multiplayer games, you don't see your own arms. It shows you basically a completely different rendition of what someone else would see. Games like CSGO are like this. It'll render something differently for when you're looking at another player versus what you actually see, because there's things like perspective and stuff like that it needs to account for, as well as it makes animations a lot easier because you don't have to render the animation for everyone looking at you. It'll just play for you. There's a lot of crazy little hacks and tricks and optimizations that go into having 3D games work the way they do.
Okay. So we've got the texture all culled and everything. Do we want to talk about some animation for a little bit and what actually goes into the animation? I haven't done much animation. I'm not a real expert on it. Some games have low quality models. Yep, just to render shadows, and what other players see are different. Yep.
That's also how they do a lot of mirrors, is they basically will just take the model with a black texture on it, or a dark texture, or like a grayed out texture if it's like a smudgy mirror, and that's how they'll do it. They'll just render the actual model on the other side of things. And you'll notice actually, probably a lot of PS1 and PS2 games, when you're playing a shooter game, if you walk up to a window, a gun will stick out of the window, and that's because they're rendering your actual model on the other side of it. It's not reflecting the light, it's actually just drawing the same room on the other side.
Because reflecting the light is way more expensive to calculate. We've talked about that in the lighting episodes.
Yeah, animations. We can talk about 2D and 3D. I have done a bit of both.
I've done a lot of 2D. I haven't done much on 3D. We kind of touched on the 2D already with the 2D animations. For all the new viewers and new people jumping in, do you guys have any 2D questions? Is there anything that you've always kind of wondered about on the 2D side, or do you wonder anything about 2D animations specifically, as we're just about to jump into animation?
Dead Island is definitely a chore.
Yeah, it was not great.
Sandy is hilarious.
I played it a little bit. It was interesting, but not enough to make me put time into it.
It was indeed a game.
Yeah, it was a game. It was meant to be played co-op. Yep. And as we know, games are fun co-op if you play them with friends. So they probably they'll just play it co-op. We don't need to make it fun. They'll be with their friends. They'll have a blast. Did they ever do translations for 2D animation, or is always a flipbook?
Yep, there is translations. This is how not all animations will be done. Words are hard right now. Before the game is rendered, I guess I should say. There's a lot of dynamic animations that go into games. They weren't really common in retro era. They're more common in games nowadays, where you'll kind of have those, more like ragdoll kind of animations. They're still not very common for 2D, but the way that's done is it uses something called bones. You basically will you'll have a 2D. Basically, it's the same stuff that we used to use for 3D, but we've translated for 2D. You'll basically have a model, you'll give it bones, and you attach points of the image to each bone. So you'll have like the top of the head is a bone that connects to the neck area, down to her torso, and then to the arms. And then you can, through code, manipulate these bones to kind of show an animation. So if you want like a 2D ragdoll effect, you would basically just apply physics to this. The 2D image will keep its shape, but its arms and legs and head will start moving and kind of wiggling all over the place.
Yeah, I actually have a utility that does 2D bone animation. It looks kind of like a Flash idea. Here's an example of 2D bone.
Yeah, I was about to bring up Flash as a very common usage of bones in 2D animation, and it's why you would see Flash animations that look very fluid even in its early stages.
Yeah.
Because you could just set the start point of an animation, an end point of an animation, and a couple keyframes in between, and then have Flash automatically tween and do the math for you to have a nice smooth animation between those points.
I've actually got an interesting app that allows you to bone and animate pixel graphics and then outputs a sprite sheet.
Ooh, that's neat.
It is.
That's pretty cool.
You know what's meant for co-op? Gauntlet.
Wizard needs food badly.
And that's a
That's always the first thing that comes to my mind.
terrible multiplayer system, Car. Terrible. I wish we knew about that when we did our multiplayer bit. We could have definitely ragged on it. Okay, so that's the bone 2D. You don't see that a lot. Again, it's only today. Retro 2D animations are exclusively sprite sheet flipbooks.
Yeah, for the most
Another
part. Sometimes there'd be keyframe tweening, but it was super rare given memory limitations.
Yeah. Another modern technique is to actually do all of your animations in 3D. Just do them in 3D. Set up fixed perspective camera, and then essentially just capture that 3D animation, turn it into sprites. Yay.
Which is actually what modern 3D game engines do, which is a wild thing. We just take a 3D object in a point of time and take a picture of it, and figure out how it would look on a 2D picture.
Yep.
But games like Mortal Kombat did that for their characters. They would just take real life pictures. You just cut out around them, and then you just have predetermined poses for everyone. Get everyone to do the same thing, and then now you have, very realistic looking character models.
So in preparation for what's coming, since we just did 2D, I've pulled up a 3D bone for people to kind of see what's going on here. This is, again, a simple one. The more complex you get. Actually, this one's fairly complex. It has all the fingers.
Yeah, it's not bad.
Got quite a few points in the back. But this is what you animate with. You don't usually animate directly with the character. You'll have the character, but you animate the bone.
Yeah, you would tell the bones how to move for a particular animation, and then put that skeleton inside the model.
Which is why you'll find in a lot of games everyone is the same height. It is so that the same animations can be applied to the same bones very easily without having to adjust for like scaling and stuff like that.
Yeah, it's really all the models have the same bones. So while on the outside they look different and can be easily identified by the player, that's really just a setting that the computer doesn't care about, and everything else is just a whole bunch of bones moving around. And then when they have their animations, you can play the animations that are built for that bone set on any model with those bones. And that's how they can easily give you different character models, and they can have the same animation. And in newer games with lots of memory, they can even do different animations for all the characters now, which is really what we expect.
And and for bones, this is what kind of led us to being able to do motion capture, as we can now record real world animations. That's why you've probably seen those motion capture suits that have all those dots on them, and that basically just tracks how we move. Like, it doesn't have to really be a human. We've motion tracked animals as well to put them into 3D animations, as well as use the same data inside games, because then we just apply that animation to the bone structure, and then now it moves in the same way.
We've even motion tracked infants.
As
Toddlers.
evidenced by Dante's Inferno.
But now that you look at this suit with all the dots on it, you can notice that each dot is actually at a hinge in the body. It is at a specific point that bends and moves, so that as they record these dots moving around, the system knows this dot's connected here, this dot's connected here, this dot's connected here, 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 and with all these points, it can create the wireframe. Or not the wireframe, create the skeleton and have the skeleton movements, and it animates it in a much more organic pattern, much easier than a person trying to move each one of these vertexes by hand, which is how it used to be done, and that's why you see that really
janky animation, where you get
really
people like
rigid movement,
skating around and only moving their arms at certain joints and not really having fingers.
I have not seen the Rajang Monster Hunter World motion capture behind the scenes. It does sound interesting. What did they use for a Rajang? Looks kind of apish.
Did they mocap a gorilla? That would be cool. Now I want to know.
Yeah, you got to tell us now. I can't show their YouTube video on my stream. Just a dude calling around. Okay, now I'm gonna definitely have to. Yeah, definitely watch that one and check out the dude trying to act like a gorilla and moving around to give this thing animation. That sounds hilarious. But yeah, hopefully this actually helps you make some sense out of those strange motion capture suits you see. All of a sudden, like you can see that shoulder, hip, rear. It's all there. It's all that's happening.
And now we've even gotten more complex to just put a lot of dots on the face. And that's how we kind of have these super realistic cutscenes now in games such as like The Last of Us, and now The Last of Us Part 2, where you really see, if you compare to like PS2 era games where it's just a mouth that moves, and maybe even if that, not just a head bob, to like full range head motion, cheek movement, brow movement, eye kind of stuttering and blinking. It's kind of nuts what we can do. We really capture the full kind of human emotion and experience.
Especially with the tech that James Cameron developed for Avatar specifically. The facial capture tech for that was insane.
The
super cool.
Rendering tech was insane for that. Do you know why we don't have games that look that good?
Because we can't render that in real time.
Because
can't be done.
At the time that Avatar was made, and here's an interesting fact for you guys that you may not know. Every frame of animation in that movie took 24 hours to render. Uh-oh, we've lost Rage.
And you're back.
Apparently my internet died? Question mark?
No, I am Rage.
You are Rage, and oh, there we go. Hey, the video's back. Okay, we're good. Yeah, every frame of animation in that, 3-hour movie of constant animation, 24 hours of rendering per frame. Think of how many frames you're watching per second.
24.
Yep. 9:35 p.m. already. The stream is going too fast. Sorry.
Here I am bitching about not being able to hit 120 FPS.
So let's do some quick math, okay? We've talked about all this stuff that's going on the scene. You have an idea of what all these assets are. They're all being pulled into scene. We all want 60 frames per second all the time, right? That's what this is, magic number. Everyone wants 60 frames per second. How long do you have to do all damage calculations, distance calculations, hit calculations, render calculations, and draw everything? How much time do you have to do all of those things in order to hit 60 frames per second?
Anybody know this offhand before Pseudo jumps in?
I do.
So movie 3D is quads, and the game industry gave up on that after the Saturn failed. Yep.
All right, I'm just going to blurt it out. It's 16.7 milliseconds.
Yeah, or
Well,
16.6.
technically 16.66666666666.
Yeah.
Floating point errors are a whole other thing that we can talk about.
Yeah. Floating point math is hard.
It is a terrifying world how common that happens.
Yep.
And it's like, your number just doesn't come back properly.
Well, and there was one generation of Intel CPUs where the math calculations on certain floats were just wrong.
Yeah, I mean, it is 1/60th of a second, but that sounds... Oh, yeah, well, of course, that makes sense. But if you think about it in an actual fragment of time, 16.7 milliseconds. Milliseconds. Just over a dozen of them. That's not a lot of milliseconds. Not a lot. And now, what's the big fad? 144 FPS. Everyone wants 144 FPS out of their crazy monitor. That's a lot of frames. You know
That's a lot of frames, and you got to do them real fast.
You know the time off the top of your head for that one, Pseudo?
Nope.
Hell yeah, 144. That's what I run is 144. 1,000 milliseconds, 144 frames, 6.944444444. But about 6.95 milliseconds. So like almost 7 milliseconds per frame is what you have to do all of the math involved, not just in the game for the hits and damage and calculations, but also the location of everything and draw it and put it on the screen and clear the buffer to get a new one going.
It's actually why a lot of games don't do those calculations based on that game loop anymore. You'll still see, like, for games that are crucial for hitbox detection, they will lock the frame rate typically because it is just too hard to have a variable frame rate to do it, which is why Dark Souls and a lot of FromSoft games are locked to either 30 or 60 FPS because you can't have the fluctuation. But you'll also notice that those games run at those frame rates very well, at least for the most part. Sometimes there's certain rooms that drop it, but you'll notice for fights at least, because that's where your hit detection is done. Like when you move, if you're doing a frame of an animation and you're checking if there's a collision, you need to check in that frame. But a lot of games nowadays, we have a lot of really kind of crazy techniques we use for hit detection and hitboxing, where we don't tie it to the animation cycle, because that way, it's the same thing with older games that were tied to it. If you can run a game at 120 FPS, your game will run technically twice as fast as if you were playing it at 60 FPS, because you're now running the game loop twice as fast. But the way it's typically done now is it's isolated, and the rendering loop runs separately, and it basically just displays a snapshot of the game as fast as it can all the time, and it's mostly more dependent on the actual graphical calculations than it is on the logical calculations.
When Vanquish came out on PC and had the 60 FPS option, they messed up and damage was tied to frame rate. Well, I mean, that's it's not like people have learned, because that was also
Dark
a thing.
Souls 2.
What was it? It was also recently in Resident Evil 2 remake. With the knife.
Oh yeah. The knife was super broken. But in Dark Souls 2, if you played on PC at 60 FPS, your durability would actually go down twice as fast as on console.
Oh, durability, huh? That's rough.
And Dark Souls 2 already has way too low durability.
I just went to change window and closed my window.
Oh no.
I'm getting set up to give away some games, is what I'm doing. So, we're basically at the end. We're getting ready to do the end. We got 5-10 minutes left of maybe questions. So if you have any questions about the stuff we've been covering or anything we haven't covered that you would like us to cover, get those requests in, get those questions in now. We'll do our best to answer them.
I mean, or we can just rant about more game building techniques. We're good at that.
Yep.
You're also welcome to join our Discord, and you can find any of us there and ask us there as well. And we can be able to answer those questions that you have. Yep,
we're very active on the Discord. We've got a whole community of game developers and designers on the Discord. So if you're into programming, you want to learn how to program, you like doing art and assets, you want to learn how to make better games, anything like that, jump on in. There's people with projects. Everyone's on the go. Fantastic little place. If you like what we're doing, absolutely hit the follow button as well. We do this every week. The rest
And
of the
if
week,
any
I
of
just
you are
play fun
interested,
games.
if any of you are interested in JavaScript programming specifically for a chatbot, we do need to actually get rolling on the chat game.
Yeah, we've designed our own game, and we're going to build it into the chatbot. We promise. We're just busy and lazy. I'm sorry. It's true.
And school is hard for me right now, but once it dies down, I'll be back on that. I want to quickly. I have to leave pretty soon. I got to take off a bit early when you guys are doing the game giveaway.
Yep.
But I do want to address Val's question because I actually do know a little bit about this. So, like, basically the question is, like, third-person camera controls suck, and they've sucked for a long time, and it's been, like, 20 or something years. Why haven't we figured this out? The typical standard is that when you hit a wall, the camera just, moves, like, it won't go through the wall. It just kind of ends up zooming in right in your back, and you just can't see anything. And the ideal world, and I think some games have done this well, it's a lot easier to do in isometric games with a fixed angle, is just have the camera move through the wall, and then you just don't render. You kind of cull the wall, and you don't render and you show it. But the problem is with most games like this, if you've ever gotten out of the map accidentally, or if you've fallen through the floor, which is pretty common in games nowadays, you'll notice that for a lot of the rest of the map, you can already see through the wall. You can kind of see through everything, and that's because the way that we do walls in this game is we only actually apply textures and render one side, because you're never actually going to see the other side. And the reason why a lot of devs don't do this is because if we allowed that camera to pop out, you would be able to see the entire rest of the map ahead of you. But that being said, we should be able to figure out some way to cull that as well, and only, don't show all of that, maybe to show like some sort of darkness. But for the time being, I guess it is pretty complicated to do. So that's why we don't just push the camera outside the wall. And I think if you just Google like an image of like, San Andreas falling through the wall, or even it happened to me at Jedi Fallen Order, you'll see that you can actually just see basically the rest of the map. If you can actually manage to get your camera outside of where you are, you'll be able to see the whole rest of them, or a big chunk of the map layout at least, because we don't render that side, and we would have to, cull that, which could be very expensive.
Yeah, and that's something that happened a lot in earlier third-person games, like Demon's Souls. It happens when you're walking through the tunnels by the big explodey bugs. Like, the camera just clips out of that tunnel. There's just not enough tunnel to contain the camera. You can just see the outside of the tunnel as you're going down along it.
Yeah, it definitely breaks immersion, and it ruins parts of the game. So I understand why they can't do that right now. Hopefully you all do.
I feel like they can. Maybe we'll start playing around with that, because I honestly don't know why we don't, have the camera push through the wall and then just a cull.
Or like deform the camera. I don't know. I guess the math, or not deform the camera, but deform the terrain. But I guess the math on pushing the camera out is just so much more difficult when the camera can be anywhere versus a fixed perspective or the Diablo thing.
Yeah, isometric.
Yes.
Because then, because then it would have to be situational, because it's only in certain areas of the game that your camera really kind of screws you up and gets zoomed right to the back of your head. Whereas if we had it just always a cull through the world, it would look really weird, because you would always just be kind of playing like The Sims, where the walls just disappear. And it can really, as Dave was saying, break immersion. Like if you're going through a tunnel, you'll be able to see like the entire tunnel, and you could be able to see around, you'd be able to rotate your camera around to see around the corner of the walls and see all the enemies kind of waiting for you and stuff like that. I feel like there has to be a solution. Like there has to be some, especially with the way technology is getting and how cost effective, we're getting. We should be able to figure out some way to, identify these areas that the camera really sucks in, and just kind of handle it, being like, what? In these certain areas, instead of zooming right in, we can detect it, and maybe just push it out and cull the wall. So maybe it's something, hopefully just gets fixed in some game, and then every other studio starts using it.
Yeah, somebody will have to come up with something.
That's usually
hey, we have nameplates again.
Yeah, Pookie requested them. There's a bunch of new people here. Hey, I'm Deus.
Hey, I'm Rage. That's Pseudo. He's being quiet.
Push the wrong push to talk about.
I am Walter Cronkite.
Okay, guys, I do have to take off.
Okay.
All right, thank you, Pseudo.
That means we're giving away games.
On the game raffle. See y'all next week.
Have a good one. Can you leave your camera on just for a little bit, hopefully?
Nope.
For sure.
Yep.
Excellent.
Nope. Nope.
Excellent.
Yep.
Just so that rage doesn't like get warped and stretched and face cut in half and all those fun things that happen when pseudo leaves.
It's fine.
So while I'm grabbing random names, we give away games. Anybody who contributes to the channel and helps us out, helps us do what we do throughout the whole lockdown to help keep people entertained, we've been giving away games. That's top 3 cheers, top 3 gift subs, top 3 donations, and anybody who's a sub automatically entered. Let's give away some stuff.
Free games.
There's been some good games too. There has. There's
There's been some
jank.
really good stuff that has gone out.
There's been some good stuff and there's been jank, but the jank has been like quality jank. Quality jank. Like Car, we gave away a copy of Indigo Prophecy. How can you go wrong with that, right?
Is Raven here?
I have no idea if
think
Egghead
so.
is here. But it's a good game.
You won a game. Contact Deus to retrieve it.
Copy of Psychonauts.
Oh, he won Psychonauts?
He did.
Sick.
Hey,
That's
Mr.
a
Grimm, I
great
saw
game.
you earlier. You still here? Brand new sub. Already get something. Lord Sutato. No, that's not right. That's not a game.
Then what is it?
Music Maker EDM Edition.
Oh,
Interesting.
that's not even slightly a game.
I almost feel bad for giving that game away. At least it's a new one, but just
Ooh, gambling.
don't put any more money into it. It's the casino courts.
There's a very cute dog licking my hand right now.
That's an accurate description. And the Talos Wind! If you're here, buddy, Talos, I'm not gonna have to track you down. Otherwise, I'm gonna have to track you down and give you a game! Yeah! Yeah! Hey, Rage, what are you doing later? Operation Flashpoint Dragon Rising. I don't know what that is.
That's, I think, a Counter-Strike mod originally? Question
Really?
mark?
Huh. Cool.
Maybe?
The military FPS. Well, I kind of assumed that much. I haven't seen this guy. I only saw him the one day. So if hopefully Captain Platypus shows up, if they don't show up within 2 weeks, we throw the game back in because I've got too many games to give away. They've got to go.
Although we are under 100 games now, I believe.
We are now under 100 games left to give away, yes. Resident Evil Revelations 2, Episode 1, Penal Colony. Okay.
That is a title.
That is a title and a half. 1, 2, 3, 4. Let's do one more. So do you want to play some Halo 3 later?
Yeah. Yeah,
Okay.
I want to play some Halo 3 later.
Hey, house kid, you still here? You hanging out? You lurking? You doing work? Got a free game for you. Free game. The game is... I think that one was already given away. Let me just double check, because I think this one was given away, but we might have a second copy of it. We do.
We did have a lot of overlap.
Rage has another copy of it, and I'm so happy to give this one to you. You're always here. You're usually active, and this is a game to have some fun with. Another copy of Tabs. That's both of our Tabs copies gone. Tabs is a game. I love that game. It's hilarious, ridiculous.
Is it a game? Question. Like,
it's a sandbox
or is it a
game.
simulator? Does it have a win condition? Does it have a death condition?
Can you even control anything?
Is it a game?
I don't know if it's a game. It's a lot of fun, though.
Yeah, that's the important thing.
It is. It is. So, tune in next week when we tackle the question, is Tabs a game? No, that's not.
Maybe actually, maybe we actually should. Maybe we should talk about like what makes a game a game.
Not next week, because we already had something planned for next week, I believe.
Yeah.
I don't remember what it was, but I remember we were already starting prepping for it.
I don't know.
Okay, Rage is going to disappear for a hot second here. Oh, is he? No, wait, it's in this chat. It's in this chat. I'm almost there.
Scrolly.
Oh, gamifying education. Yes. Health.
Oh, yes.
Health and educational benefits of gaming is what we're doing next week. And it's going to be very interesting.
Fun.
Very interesting.
Very
There's
cool.
Lots of cool stuff happening in the health and education worlds with gaming. And I've even got my own private stories dating back to when I worked in high schools and secondary schools, post-secondary schools. I've done a lot of stuff with computers. I have.
It's true.
And I will go eat dinner now. However, I will be back with some Halo 3 with Rage.
Yeah.
So we're going to do up some multiplayer Halo 3 a little later tonight. Should be fun. I haven't played Halo 3. It's going to be a blind for me.
Really?
Yeah, I never played Halo 3. Never touched it.
Yeah, Deus is blind.
Come on. You guys modded out the word blind? What is wrong with you, Twitch?
No, that was I was gonna say that was Automod. That wasn't us.
Yeah, I said Twitch. Bring enough Mountain Dew for the entire class. Yeah, next
Only
week's gonna be
if you bring the
a lot of fun.
Doritos.
I've already got the Doritos and Sun Chips.
I don't have any Doritos. I want Doritos.
I got big bags of them from Costco. Both of them.
I'll break out some Miss Vicky's salt and vinegar then. So
Oh.
there.
I have some of those too, actually.
I'll be like crunching in the mic and everybody will hate me. Great.
Work gives us a munchie budget for home still.
Nice.
A lockdown. So, I hope you all enjoyed. Absolutely follow if you don't. We do this all the time. The rest of the time I'm playing blind games. First time you get to see how somebody like me tackles the game that he's never seen before. I like to talk about what's going on in my head while I do it. And then the three of us also get together and review any game requested to be played. So you get to hear what our thoughts are on We Happy Few when I finish it. Spoiler, it's good.
It's weird.
Yes.
It's very strange.
Weird is an accurate description of that game. So, until I get to see you later with the Halo. Oh no, Rage, are you okay?
What is going on with my computer today?
I don't know. So, before I get to see you later with the Halo 3, I'm Deus.
I'm Rage, and that was
He's
Pseudo.
And may all your shots be headshots.